Imagine a world where computers learn from experience. This isn't science fiction, it's machine learning. Machine learning powers everything from personalized recommendations to medical diagnoses. By understanding machine learning, we can unlock its potential and shape the future. Are you ready to explore the fascinating world of machine learning? Let's begin. In today's digital age, we are surrounded by data. Machine learning helps us navigate this data deluge, extracting meaning and knowledge. As technology advances, the role of machine learning becomes increasingly vital. Humans learn through observation and experience. Machine learning mirrors this process, enabling computers to learn from data without explicit programming. The more data we feed these algorithms, the better they become at making accurate predictions. By understanding the basic principles of how machines learn, we can demystify this transformative technology. The seeds of machine learning were sown in the mid-20th century. Early pioneers dreamed of building machines that could think, learn, and solve problems. One of the earliest milestones was the development of the Turing test by Alan Turing. Scientists began exploring ways to teach computers to learn from data. A new paradigm was needed, one that allowed machines to learn from data without explicit programming. In 1957, Frank Rosenblatt introduced the perceptron, a groundbreaking model inspired by the human brain. The perceptron was a simple mathematical model that could learn to classify data into different categories. It mimicked the way neurons in our brain process information. The perceptron's ability to learn from data without explicit programming was a significant breakthrough. However, the initial excitement surrounding the perceptron was met with limitations. Despite the setbacks, the perceptron laid the foundation for future advancements in neural networks and deep learning. The limitations of early AI systems led to a period of reduced funding and interest in the field during the 1970s and early 1980s. Despite the setbacks, research in machine learning continued in specialized areas. The resurgence of machine learning began in the late 1980s with the development of backpropagation. This breakthrough, coupled with the increasing availability of data and computing power, breathed new life into the field. The AI winter ultimately paved the way for the remarkable progress we see today. The 21st century ushered in the era of big data, with an explosion of digital information. Deep learning, inspired by the structure of the human brain, emerged as a game-changer. Deep learning models have achieved remarkable success in areas like image recognition, natural language processing, and machine translation. We are now witnessing the transformative power of machine learning in various aspects of our lives. The journey from the early days of thinking machines to the age of big data and deep learning has been marked by both challenges and triumphs. At its heart, machine learning is about extracting knowledge from data. The more data we feed a machine learning model, the more it learns and the better it becomes at making accurate predictions. High-quality data is accurate, relevant, and representative of the problem we want to solve. For example, if we want to train a model to identify different species of birds, we need a dataset with labeled images of various bird species. The amount of data is also essential, especially for complex tasks. Deep learning models thrive on massive datasets. Data is the fuel that powers the machine learning engine. Machine learning algorithms are the engines that drive the learning process. Each algorithm has its own strengths and weaknesses, making it suitable for specific types of problems. Some popular machine learning algorithms include linear regression, predicts a continuous output variable; logistic regression, used for classification problems; decision trees, used for both classification and regression tasks. Once we have the data and the algorithm, The next step is to train the machine learning model. Training is like teaching the machine to learn from the data. During training, the model is fed the training data, and the algorithm adjusts the model's internal parameters to minimize errors. The training process involves feeding the model with labeled data, calculating the error, and adjusting the model's parameters. The goal of training is to create a model that can generalize well to new, unseen data. This ability to generalize is what makes machine learning so powerful and useful in real-world applications. After training a machine learning model, it's crucial to evaluate its performance. We need to measure how well the model can predict the output for new, unseen data. This is done by using a separate dataset called the testing data. Several metrics can be used to evaluate the performance of a machine learning model depending on the type of problem. Accuracy measures the percentage of correct predictions made by the model. The choice of evaluation metric depends on the specific application and the relative importance of different types of errors. The ultimate goal of machine learning is to make predictions about new, unseen data. Once the model is trained and evaluated, we can deploy it to make predictions on real-world data. For example, a trained image recognition model can be used to automatically tag photos on social media. The applications of machine learning are vast and constantly expanding. As we continue to generate more data and develop more powerful algorithms, the potential of machine learning to solve complex problems and improve our lives is limitless. Consider the way we navigate the digital world. Every time you open Netflix, a silent algorithm recommends movies based on your viewing history. Similarly, online retailers use machine learning to suggest products you might be interested in. Machine learning also powers spam filters, protecting our inboxes from unwanted messages. These everyday examples demonstrate the pervasive influence of machine learning in our lives. From entertainment to shopping to communication, machine learning algorithms streamline tasks, personalize experiences, and enhance efficiency. As we become more reliant on technology, the role of machine learning in shaping our digital interactions will only continue to grow. Machine learning is revolutionizing healthcare and security. Machines assist doctors in diagnosing diseases earlier and more accurately. Algorithms analyze medical images, detecting subtle anomalies. Early detection improves treatment outcomes and saves lives. In security, machine learning aids in fraud detection and crime prevention. Financial institutions analyze transactions in real time, identifying suspicious patterns. Law enforcement uses machine learning to predict crime hotspots. Ethical considerations remain crucial in the development of these technologies. Machine learning tackles complex challenges in healthcare and security. One of the most exciting frontiers in machine learning is natural language processing, or NLP. This field focuses on teaching machines to understand and communicate in human language, bridging the gap between humans and technology. Virtual assistants like Siri, Alexa, and Google Assistant are prime examples of NLP in action. These assistants use machine learning to understand our voice commands, respond to queries, and perform tasks. NLP also powers machine translation, breaking down language barriers and connecting people across cultures. Machine translation engines use vast amounts of text data to learn the nuances of different languages, improving accuracy and fluency over time. This technology has revolutionized communication, making it easier than ever to access information, consume content, and connect with people from all over the world. Chatbots, powered by NLP, are transforming customer service. These AI-powered assistants can handle a wide range of customer queries, providing instant support and freeing up human agents to focus on more complex issues. As chatbots become more sophisticated, they are becoming increasingly adept at understanding natural language, providing personalized responses, and resolving issues efficiently. The advancements in NLP are making technology more accessible and intuitive. Machines are learning to speak our language, understand our intent, and respond in meaningful ways. This progress opens up a world of possibilities for communication, collaboration, and creativity, blurring the lines between human and machine interaction. Imagine a world where cars drive themselves, navigating busy streets and highways with precision and safety. This is the promise of autonomous vehicles, driven by machine learning. They rely on sensors, cameras, and algorithms to perceive surroundings and make decisions, learning to adapt to different road conditions and traffic patterns. Autonomous vehicles could revolutionize transportation, making it safer and more efficient. They offer mobility options for those unable to drive, but challenges remain, including ethical and legal issues. Addressing these is crucial to shaping the future of transportation. Machine learning is no longer a futuristic concept confined to science fiction. It's a transformative force shaping the world around us. From the algorithms that recommend our next movie to the machines assisting doctors in diagnosing diseases, machine learning is impacting our lives in profound ways. As we generate more data and develop more powerful algorithms, the potential applications of machine learning will only continue to expand. The future holds exciting possibilities. Imagine personalized education tailored to each student's learning style, powered by machine learning algorithms that adapt to their strengths and weaknesses. Envision a world where precision agriculture, guided by machine learning, optimizes crop yields, reduces waste, and enhances food security for a growing population. Consider the potential of smart cities, where machine learning optimizes traffic flow, manages energy consumption, and improves the quality of life for residents. The journey into the world of machine learning has just begun. By understanding its basic principles, its historical evolution, and its real-world applications, we can embrace its transformative potential and navigate the exciting possibilities that lie ahead. As we venture further into this era of intelligent machines, collaboration between humans and machines will be key to unlocking its full potential and shaping a future where technology empowers us to solve complex challenges, improve our lives, and create a better world. As we stand at the precipice of this new age of machine learning, it's crucial to ask not just how, but why. Why are we developing these powerful tools? What problems are we trying to solve? The answers to these questions will shape the trajectory of this technology and its impact on humanity. Machine learning, like any tool, is not inherently good or evil. It's a powerful instrument that can be used for both beneficial and detrimental purposes. In healthcare, it has the potential to diagnose diseases earlier, personalize treatments, and accelerate drug discovery, ultimately saving lives and improving well-being. In environmental science, machine learning can analyze climate data, predict natural disasters, and optimize resource management, helping us address pressing global challenges. However, the same technology can also be used for malicious purposes. Facial recognition algorithms, for example, can be used for surveillance, potentially infringing on privacy and civil liberties. Autonomous weapons systems, driven by machine learning, raise ethical concerns about accountability and the potential for unintended consequences. As we develop increasingly powerful machine learning systems, it's imperative to establish ethical guidelines, regulations, and safeguards to ensure these technologies are used responsibly for the benefit of humanity. The future of machine learning is a tapestry woven with threads of both promise and peril. On one hand, it holds the potential to solve some of humanity's most pressing challenges, from curing diseases to mitigating climate change. Imagine a world where personalized medicine tailors treatments to individual genetic profiles, where smart grids optimize energy consumption, and where intelligent transportation systems alleviate traffic congestion. On the other hand, the rise of intelligent machines also raises concerns about job displacement, algorithmic bias, and the potential for misuse. As machines become increasingly capable of performing tasks once thought to require human intelligence, we must prepare for a future where work is redefined and new skills are needed. The issue of algorithmic bias, where machine learning systems perpetuate existing societal biases present in the data they are trained on, demands careful attention. Ensuring fairness, transparency, and accountability in algorithmic decision-making will be crucial to prevent discrimination and ensure equitable outcomes. The potential for misuse of machine learning, whether for malicious hacking, disinformation campaigns, or autonomous weapons systems, underscores the need for robust ethical frameworks, regulations, and international cooperation. Section 3. Beyond the Horizon, the future of intelligence. As we venture further into the uncharted territory of artificial intelligence, we must grapple with fundamental questions about the nature of intelligence itself. Can machines truly think? Will they ever possess consciousness or emotions? These questions, once relegated to the realm of science fiction, are becoming increasingly relevant as machine learning systems become more sophisticated. While we may not have definitive answers yet, exploring these questions is essential for understanding the potential implications of artificial intelligence. The development of artificial general intelligence, or AGI, machines capable of performing any intellectual task that a human being can, remains a distant goal. However, the rapid pace of progress in machine learning suggests that we may be closer to achieving this goal than we realize. The prospect of AGI raises profound philosophical, ethical, and societal questions that we must address collectively. How will we coexist with machines that may surpass us in intelligence? What will it mean to be human in a world increasingly shaped by artificial minds? These questions challenge us to re-examine our assumptions about intelligence, consciousness, and the very essence of what it means to be human. Section 4. The Dawn of a New Era. We stand at the dawn of a new era, one where machines are no longer merely tools, but collaborators, capable of learning, adapting, and augmenting our own capabilities. This era holds immense promise for solving some of humanity's most daunting challenges and unlocking new frontiers of knowledge and innovation. However, it also demands a profound sense of responsibility, ethical awareness, and a willingness to engage in thoughtful dialogue about the implications of this transformative technology. The future of machine learning is not predetermined. It is a future we are actively shaping through our choices, our values, and our collective imagination. By embracing a spirit of curiosity, collaboration, and ethical awareness, we can harness the power of machine learning to create a future where technology empowers us to build a more just, equitable, and sustainable world for all. The journey into the age of intelligent machines has just begun, and the path ahead is filled with both challenges and opportunities. Let us proceed with wisdom, courage, and a shared commitment to shaping a future worthy of our shared humanity. Section 1. Learning Styles, a machine's perspective. Just as humans learn in different ways, machines have their own learning styles. These learning paradigms dictate how machines process information and extract knowledge from data. Understanding these different approaches provides insight into the versatility of machine learning and its ability to tackle a wide range of tasks. Let's explore the core learning styles that power intelligent machines. Imagine teaching a child to identify different animals. You might show them pictures of cats, dogs, and birds, labeling each one. This is similar to supervised learning, where the machine learns from labeled data, mapping inputs to outputs. Now imagine that same child playing with a puzzle, figuring out how the pieces fit together without explicit instructions. This mirrors unsupervised learning, where the machine explores unlabeled data, identifying patterns and relationships on its own. Reinforcement learning takes inspiration from how we train pets. We reward desired behaviors, reinforcing those actions over time. Similarly, a machine learning agent in a reinforcement learning setup learns through trial and error, receiving rewards for taking actions that lead to a desired goal. These different learning styles offer unique approaches to knowledge acquisition, allowing machines to adapt to diverse tasks and data environments. Section 2. Supervised learning. Learning with a teacher. Imagine a student learning a new language with a tutor. The tutor provides guidance, corrects mistakes, and offers feedback. This is like supervised learning in machine learning. The algorithm learns from labeled data, each input paired with the correct output. It learns a mapping function to predict outputs. For example, in spam detection, emails are labeled as spam or not spam. Supervised learning is used in image recognition, spam filtering, medical diagnosis, and credit scoring. Its effectiveness relies on the quality and quantity of labeled data. Acquiring and labeling data can be time-consuming and expensive. Section 3. Unsupervised learning, discovering hidden structures. Imagine a child sorting blocks by color or shape without instructions. The algorithm explores unlabeled data to discover hidden structures and patterns. Clustering groups similar data points based on shared characteristics. Anomaly detection identifies unusual data points. Applications include customer segmentation and recommender systems. Unsupervised learning uncovers hidden insights in complex data. Section 4. Reinforcement learning. Learning by trial and error. Imagine training a dog to fetch a ball. You reward the dog with praise and treats when it successfully retrieves the ball. This trial and error approach is the essence of reinforcement learning. An agent interacts with an environment to maximize a reward signal. The agent receives feedback in the form of rewards or penalties. Through repeated interactions, the agent learns a strategy to maximize its reward. Section 1. The Machine Learning Mosaic. As we conclude our exploration of the fundamentals of machine learning, it's essential to appreciate the intricate tapestry this field represents. We've journeyed from the early aspirations of creating thinking machines to the current reality of algorithms shaping our digital lives. Like a mosaic, machine learning is composed of diverse elements, each contributing to the bigger picture. We've delved into the historical milestones that paved the way, from the groundbreaking perceptron to the rise of deep learning. We've explored the core principles that underpin machine learning, from data's crucial role as the fuel for learning to the algorithms that act as the engines of knowledge extraction. The different learning styles, from supervised to unsupervised and reinforcement learning, further underscore the adaptability and versatility of this technology. Machine learning is not a monolithic entity but rather a collection of tools and techniques, each suited to specific tasks and challenges. Understanding these nuances allows us to appreciate the breadth and depth of this field, from its ability to personalize our online experiences to its potential to revolutionize healthcare, transportation, and countless other industries. Section 2. Embracing the future, shaping our destiny. The age of machine learning is not a distant future. It's the reality we're living in today. The algorithms we've discussed are not confined to research labs. They're embedded in the technologies we use every day. From the recommendations we receive on streaming platforms to the spam filters that protect our inboxes, machine learning is shaping our digital interactions in profound ways. As we generate more data and develop more sophisticated algorithms, the influence of machine learning will only continue to grow. This transformative technology presents both unprecedented opportunities and complex challenges. It has the potential to solve some of humanity's most pressing problems, from curing diseases to mitigating climate change. Yet it also raises concerns about job displacement, algorithmic bias, and the ethical implications of increasingly intelligent machines. The future of machine learning is not predetermined. It's a future we are actively shaping through our choices, our values, and our collective imagination. By embracing a spirit of curiosity, collaboration, and ethical awareness, we can harness the power of machine learning to create a future where technology empowers us to build a more just, equitable, and sustainable world for all. Section 3. A universe of possibilities. As we stand at this pivotal juncture in technological history, it's essential to remember that machine learning is a tool, an instrument that can be wielded for good or ill. The responsibility lies with us, the creators and users of this technology, to ensure that it is developed and deployed ethically, responsibly, and for the benefit of humanity. The universe of possibilities that machine learning unlocks is vast and awe-inspiring. Imagine personalized education tailored to each student's learning style, powered by algorithms that adapt to their strengths and weaknesses. Envision a world where precision medicine tailors treatments to individual genetic profiles, optimizing health outcomes and enhancing well-being. Consider the potential of smart cities, where machine learning optimizes traffic flow, manages energy consumption, and improves the quality of life for residents. These are just a glimpse of the transformative potential that machine learning holds. By embracing a spirit of collaboration, fostering ethical development, and prioritizing human well-being, we can navigate the challenges and seize the opportunities presented by this revolutionary technology, shaping a future where machines augment our capabilities, expand our horizons, and empower us to create a better world for generations to come.